Hi everyone, welcome back to my YouTube channel and to the start of another hands-on new project. I'm finally getting around to starting this build as the weather has picked up lately. This project has been delayed for months, very close to a year. So as you can see, I decided to come to one of my favourite locations to start this project off. So I'm currently sat on the edge of the River Foyle at the Gribben Quay pier to the left of me at Brady, Northern Ireland. Some may notice I've been here before for other projects on my channel. I'm hoping it doesn't rain on the bike seen behind me and all the gadgets, the accessories laid out in front of me. So right across the quay. Well, until I complete my discussion, so hopefully the rain stays away here. I will show and discuss these items after I finish discussing the bike here first. So I have decided to split this project into multiple parts due to the enormous amounts of work required. This video, part 1, will start with a short introduction, then I will give a rundown of the state-of-the-art bike seen behind me here I purchased for this build. Then I will proceed by focusing on all the gadgets, the accessories laid out on the quay. Just a little discussion of what exactly I have purchased for the build and why. Okay, so this project evolved because I wanted a high spec, superior bike, an e-bike, with a high output motor, high wattage motor, also a high performance bike such as high performance brakes, high performance suspension. I also wanted a bike with good build quality. I also wanted, well, everything perfect. I wanted the best. So finding something like this to this spec I seek is very difficult. So it's basically a needle in a haystack. Impossible. Not only that, but it could cost around £10,000 or very close to £10,000. I would say more for the spec that I'm building this bike too, because it's a custom build. So the difference here is that I'm building my own battery pack and the entire bike to a standard way beyond. I have just surpassed the 50% limit of that figure with everything I have purchased. So laid here on the pier and the bike of course. So everything that I've purchased for the project, which I will demonstrate here in a moment. Okay, so I will talk about cost in a moment when I'm going over everything, just in case anybody wants to know or wants to go down the same road as me by building a bike to the standard. So I could have had another luxury performance car in my street for the cost of this project alone. However, in the end up, it will be another unique project to look at, if not driven. So to start this project off, I decided to purchase a top of the range bike. It's one for riders looking to get more serious with their trail riding. It contains all the necessary components to make this build out of the ordinary and different from anything you can purchase once complete. What I mean by that is with all the accessories behind the camera here and with my custom battery pack that will follow, and the battery enclosure, the casing, it will all come together as one with this high spec dual suspension bike to deliver a project with an extraordinary standard quality. So before we move on here, I should say I have spent a few months researching battery pack designs for this build. So this will be my main focus when I get into the project itself. The main area of this project build will be designing and building a state-of-the-art lithium battery pack for this 29-inch Boardman 8.8 MTR mountain bike. The reason being, the battery packs you buy online are mostly Chinese and very cheaply made, made in production. So they also contain cheap cells and poor design quality. For example, for the pack I'm building, I have actually purchased the most advanced cells, Samsung 2170050S cells. So these cells are the most advanced cells across the world at present. I will get more into detail on that in the next video that follows. So you don't know what you're buying within these sealed battery packs, quality and design wise. So I just sourced all my components from trustworthy sources to do this myself. Not only this, but I also wanted to make the most of the little capacity I have available to mount the battery pack within the frame of this bike. So within the main triangle here seen at this point. So I've actually had to turn this shock upside down to put the valves to the top of it, the little control valve, and yeah, to make more room for the batteries that will be placed in between the frame. So any battery pack you would buy would not be taking advantage of this entire space, but would just sit roughly in between the tubes. So if you can imagine, I'm hoping for a, well, I'm not hoping, I have designed my battery pack for a 50 amp hour 72 volt battery. So if I was to place a battery that you can purchase inside here, you don't have much room, so I would probably end up with a 20 amp hour battery, probably less. I would probably need to put the battery down here or somewhere stupid, which I don't want to. So the idea here is to make the most of this entire area, to increase the capacity of my battery safely in a compact manner. For example, here's a template I created for my battery pack. So if I bring this up nice and close here, you can see that I have placed all these little circle tabs, stickers, to represent where the cells will be located. So there's 50 cells here, and there will be also 50 cells at the other side. And there will be a serious connection between this battery pack at this side, bank 1, and bank 2 at the other side. So it's quite interesting. So I'm going to move on now to the bike, and then we're going to move on to the accessories, the gadgets, everything that's laid out here on the key, and hopefully it all goes well. Okay, so the wind has picked up, it has spiked. Hopefully none of this blows into that river. So we're going to talk about, well, all these components, but quickly, we're not going to focus on them too much. There's the wind going mad now. So the bike's still sitting in the same spot, more or less. And hopefully it doesn't get blown over, because it's quite light at the minute. So the motor used for the road will be much smaller at a legal requirement of 250 watts. Running with the 3000, there's everything going to blow in the river. Okay, so damage to the gripper here, sadly, and to this brake lever. So the one came out of nowhere, as you can hear there, just after I finished the introduction. So I'm going to stop this video, I'm going to get these parts replaced, and then I will start doing this again. So that's the only damage to it, there and there, and this pedal too. So I'm just going to order new ones. Annoying, typical Northern Ireland. Okay, so after the handling I had at the key a couple of days ago, I think it's only best to continue this project, this video in this office. So I have brought the bike into the office, and hopefully you can see it nice and clear. I don't like videoing indoors because the lighting conditions is reduced, but it's better than wrecking the bike. So if you don't know what I'm talking about, the bike was damaged during the making of this video, the first part, the introduction. So after I made the introduction, the wind actually came down the foil, the river, when the tide was coming in, and blew the bike over on its lid. And it actually wrecked the bike in 3 places. Well, it destroyed 3 of the parts. Well, when I say destroyed, it marked them, it didn't bend them or nothing, but my OCD seriously kicked in. So at the right hand side of the bike, the brake lever is damaged. One of the grips is damaged on the right hand side, and the pedal is also damaged. So what I've done here is I've ordered up new parts, the parts that I have ordered are, well, more advanced parts, apart from the brake lever, which is genuine. So the grips that I've ordered are now, well, I've ordered 2 sets. I've ordered a green set and I've ordered a black set, and I think the grips, the brand name is Death Grips. So I'm going to continue on with this little video in this office. If you haven't seen the video of the damage of the bike and everything that went wrong that day, it's uploaded to my channel yesterday. Well, a day before I started recording this video again. So I'm going to follow on here now and give an overview of the bike. Then I will move to the accessories, and hopefully you will see them nice and clear on the floor. Outside's quite dull today, and I don't want to go out because it's cold too. So I'll continue on here. So the main reasons I selected this bike was because of its appealing looks, but mainly its critical components. For example, the brakes, the suspension and the wheels. So the frame's tubes, the aesthetic arrangement is very pleasing to look at, especially with that colour. So I've imagined this bike finished with a mirror grade battery pack enclosure alongside that vibrant colour at this triangle structure seen here. So if you can imagine all the cells in between this part of the frame, and a cover that will be, well, it will slide in at this side and at the other side, or it might be just one enclosure itself with a hatch that the cells all are placed into. I'm not sure the way I'm going to do that yet, but we will get to that stage in later date. So the hydraulic brakes with these large rotors that are 180mm front and back should provide impressive stopping power at higher speeds that I hope to achieve. Also, the bike having 29-inch wheels means it will handle much better at these higher speeds. So I'm talking about speeds in excess of 60 miles per hour or over. We haven't got to that stage either, but definitely up around there. Okay, so I should point this out before I go any further. The stainless steel cover that I have talked about there will contain the 200 cells. It's there to enhance the look of the bike, yes, but its main reason is for the safety of the user, being me. So just in case the battery pack decides to blow out or explode, or just say it blows fire out or fireballs out towards my legs, we don't want that. So the stainless steel cover is there to restrict that from happening. So one final thing here before we move on to other crucial aspects of the bike. So the suspension has huge amounts of travel to soak in that rough terrain. The adjustable air front forks have 150mm of travel, and the rear have 145mm of travel, whilst also being adjustable air. So I wanted a dual suspension bike, which makes my life much more difficult for this project. Okay, before we move on to the interesting part, which is all the gadgets that I have purchased for this bike, I want to just give a final rundown on some of the components that I have not talked about. So I should point out the stand on the ground here. So this stand is the same stand that was used on the key which held the bike up. So it didn't do a very good job at the time because the bike's that light. So the bike only weighs 16 kilograms. The stand itself is damaged here and there, so it's chipped, the paint's chipped off it. The stand come from factory with a wee light skift of paint on it anyway, so I wanted, or even powder coat, whatever it is, I want to apply my own standard to the actual stand itself to have a thicker coat of powder on it. So I might even change the colour, we don't know yet. I might even change it to green, I'm not sure. Or some nice candy colour. So now moving on to the bike itself. If we focus on the saddle here first. So the saddle itself is Boardman. There is a Satori dropper post on it, which is controlled using this mechanism on the handlebars. So that is 150mm from top to bottom using this mechanism. The handlebars themselves are 780mm long, or wide even, shall I say, from this grip to the damaged grip, which is at this point. It's not really noticeable, but it's noticeable to me. So the brakes we've already discussed. They are, what do we see, hydraulic brakes, I would say, but the brand of them is Tektro. They have these little reservoirs here at this point. This reservoir is being changed. Well, I am changing out the lever from the new reservoir I'm getting because of chipped here at this point. Not really noticeable, but noticeable to me. We're going to move to, I should point out before we go any further here, you probably noticed these brake lines and the cable for the dropper post hanging down. The reason they're hanging down is because I dropped them to make the template for the battery pack that you've seen earlier at the start of this video. So now moving on to the gears. We have no derailleur at the front, but we have an 11-speed derailleur at the back. So the largest cog here has 51 teeth, so that's a really low gear. However, that will not be used when I attach my wheel and my motor to the bike. So I think we're losing 2 gears. I think it goes down to 9 speed. Not sure, but we will find out in the next video clip because that's coming next. So I think I've discussed everything here. Well, the tyres themselves. So the rims, the tyres come tubeless ready. So the tyre brand is Maxxis Minion. As I've said there, the bike is 16 kilos. It's quite light, but it will be much heavier when I attach 200 batteries in there in that A section and the heavy motor at the back. So that's everything. I should point out too, this crank here needs to be well, altered. So if you can imagine, if I place the camera straight down here, this crank needs widened out to allow for the cells, the battery pack, because at the minute, if I was to pedal this bike with the pack in place, if you can imagine it being in place, these pedals, the crank arms would hit the battery pack. So I have to modify the actual shaft in here at this point. Hopefully that makes sense. So that's it, everyone. We're now going to move on to the accessories. So all's good. Okay, so the sun has come out and we are stuck inside, sadly. So we are now at that interesting stage I've been talking about. I'm going to do this a different way from the approach I was taking at the riverside. To keep things simple, I have now placed all the items into different groups to discuss swiftly before we finish up. We will start with the wheels, then move on to other critical components for this e-bike. First, some that know me will know it's a problem I've always had. Everything needs to be pristine, the best or perfect. That goes for the batteries, the battery pack, the bike and all the components, the extras that follow. In order for me to settle my OCD, I needed to have an MTX39 front rim for this bike, so that it matched the rim seen here laced with this motor hub. This item was extremely hard to source. It took 9 months of pestering the seller I purchased this kit from. Obviously it was not required, but I think it would have ruined the bike's appealing looks by not having it. So the hub seen within this rim matches and fits between my fork and onto my axle through bolt. The axle bolt is 15mm in diameter and the width of the hub is 110mm. So if I stand this rim up, and if you look across the hub there, it's 110 from one end to the other. My brake rotor on my bike also fits directly onto this hub. Okay, so moving away from the front wheel and now onto the rear wheel. So the motor kit I have selected for this bike has a 3kW motor that will be used for bike trails. However, I will be making the bike adaptable for it to be switched from road highway use to off-road trail mode, beast mode. So the motor used for the road will be much smaller at the legal requirements of 250 watts. Running with the 3kW motor, I will have peaks of 5kW, so 55 miles per hour with the beast of a battery that I have designed that will follow in part 3 of this project. So the peak of 5kW will provide speeds in the range of 55-60 miles per hour, but it all depends on the battery. That's why I am designing my own battery here. So I will follow on here by briefly discussing some of the control and the monitoring modules before we look at the cells. Keep in mind, this video is only an introduction. I will go more into detail on the design and the manufacture of the battery pack in part 2, 3, 4 and 5, or however many parts it may take. So here we have the 80 amp controller I selected to obtain the motor's optimum performance. So as far as I mind, there was a couple of options available here. So other accessories seen on the floor here come with the kit, such as this UKC1 LCD color display and this box of accessories. So we have the twist throttle here. So I won't be using this twist throttle as I want to keep the new death grips that I've recently purchased. I will probably design and make my own quad-like throttle rather than using this twist throttle. So if you can imagine, I will be pushing a lever rather than creating this rotation. Okay, so moving away from the control side and now focusing on the monitoring side. So I've selected this Daily Smart 150 amp battery management system with this smart LCD touchscreen to monitor all the parallel grips, which can also be done from an app via Bluetooth. So we have this little hardware device that plugs directly into the BMS. So also we have the screen that plugs directly into the BMS with these little wiring looms. So I created this little diagram to explain this a little clearer. So this is how I will configure my battery pack. 2 banks linked closely at this series connection. So this BMS is selected for the battery configuration of 20S 72 volts. So basically the BMS will monitor the voltage of the cell groups and the overall current passing into and out of the battery using these little series connections. So I'll just sort of demonstrate where these connections are placed. So if you can imagine this being the negative point of the battery, we will then have a series connection here, 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 right around 20 times. So it monitors each one of the parallel groups. So if anything happens out of the ordinary, the BMS will shut off to protect me and the battery itself. So this BMS was selected or determined on how much current I needed. Therefore, I have overrated widely to reduce any voltage sag. So I'll give a little example here. So an 80 amp battery, well, a battery capable of supplying 80 amps will work on a 60 amp BMS. However, you will suffer voltage sag. That's not great for the battery's longevity. So I went bigger in this case. So my controller's 80 amp. This is 150 amps. So I've almost doubled here. Okay, so here we have the 200 cells that I have sourced, that I require for my state-of-the-art custom battery pack. So in this box we have 130 cells, in this box we have 70 cells. So these are actually Samsung's latest leading model and are also known to be the most advanced cell on the market across the world at the moment. I selected these 21700 cells over the 18650 type cells for various reasons. The main reason being its larger capacity, as each individual cell produces a massive 5000 milliamp hour. These 50S cells are the upgraded model from the 50E cells, which have a 10 amp discharge rate. The 50S cell has more power on continuous discharge at 25 amp, making it an amazing and leading cell worldwide. But it also makes it more expensive, driving up the cost of this project. I will attach the cost of the project at the end of this video. So, going back to the little diagram to give an insight on how the pack will be set out with these cells. So I will configure the pack to 20 series 10 parallel as previously mentioned. So that will be 20 groups of 10 cells in parallel. This will give me an output of 72 volts nominal or 84 volts full and a capacity of 50 amp hour. So a wee example here. Let's say I was to place the 50E cells in this configuration in the parallel branch seen here. So that's 10 amps times 10, or the other way around, 10 cells times 10 amps. That equates to 100 amps continuous current. So that's what I can draw from the battery pack continuously. But see, if I'm using these cells that I have on the floor here, the 50S, I can draw 250 amps continuously. Because if you go 10 cells in the branch times 25 amp, so that's the rate, the discharge rate of the cell, which is 25 amps. That gives me 250 amps. That's huge. So you're probably wondering why such a high current rating. Let's say in the future I decided to upgrade my rear motor or add another motor at the front wheel. I may as well design and manufacture the battery pack to a high specification now rather than later. Therefore, if maximum current down through the parallel branch seen here to 10 cells equates to 250 amps peak, this means that my connections, it being nickel or copper, needs to be rated to handle the same series current of 250 amps, and the parallel branches need to be rated respectively, or it all goes downhill fast from here. So I'm going to move on now to the actual charger devices that I have selected for my e-bike, well, a charger, and then I'm going to follow on with other interesting gadgets. So yeah, not going to go into this in too much detail yet. This will come in part 2, 3, 4 and 5, and yeah, well, maybe more parts, we don't know yet. But yeah, moving on. Okay, so moving on to the charging of the e-bike. So I selected or purchased this lithium charger, which has an output voltage of 84 volts, and a charge current of 20 amps via this plug, this connection. So this is required for me to charge the 20 cells in series. So the series groups. So one of these cells, the charge voltage is 4.2 volts. So if you multiply that by 20 cells in series, that equates to 84 volts. So 84 volts is the charge voltage of my battery pack. So I could have bought a cheaper version, a cheaper charger, but I like how zero moisture can get inside this unit and how the entire body is actually a heatsink with the additional cooling fan seen here. So with my cell spec and the battery configuration that I have set, a 20 amp charger is fine. So I'll go into that in a little more detail here. So the 50S cell's standard rate of charge is 2.5 amps and rated charge is 6 amps on the datasheet. This is per parallel cell arrangement. For example, if I was to place 10 of these cells in parallel, the standard charge is 25 amps, whilst rated would be 60 amps. So I have gone with a 20 amp charger here as I decided to underrate it rather than sit on the standard limit of 25 amps. So I'm in no rush to actually charge the bike when it's built. I could have went with the 25 amps, but 20 amps is fine. The 25 amp charger is a little more expensive than this one, but not by much. Okay, before we move on here, I just want to do a little sketch to visualize what it is I'm exactly talking about. So I will zoom in here nice and close. Maybe too much. So I'm going to start off here by sketching one parallel cell arrangement. So this will be the cell arrangement within my battery pack. Okay, there we go. So I'll zoom out here again. Okay, so this charger, the output is 84 volts. The charge current is 20 amps. So that 20 amps within this cell arrangement will be split evenly between the 10 cells. So down through this first cell we will have 2 amps. So that is a charge current. This same charge current will exist in this branch, this branch, this branch, right through. So I'm well within the standard limit, the standard charge rate of 25 amps or 2.5 amps per cell. So moving on now to the charging time of my battery pack. So my battery pack is 50 amp hour. So that 50 amp hour, if I was to just do a wee calculation here to demonstrate where that 50 amp hour is coming from. So I have 10 cells. So 10 cells times the capacity of each one of these cells. So that's 5,000 milliamp hour. So that equates to 50 amp hour battery. Or battery pack. So 50 amp hour divided by the charge current, which is 20 amps. That gives us a charge time of 2.5 hours or thereabouts. So that's empty to full. So generally the slower you can charge the battery pack, the better. But you don't want it taking days either. I can also limit the max and the minimum charge voltage of the pack via the BMS to extend cycle life at the expense of the overall capacity if I decide to do this. Okay, so before we move on, I just want to finally touch on the cost of charging my battery pack once it's made. So I'll use this sheet of paper here. So the energy capacity of my battery pack will be in watt hours. So that will be the battery voltage times the capacity of my battery, which will be in amp hour. So if I get 72 volts multiplied by 50 amp hour, that will, it equates to 3.6 kilowatt hours. So that's the energy capacity of my battery pack. So if I multiply that by the rate, my current rate of, per unit of the supplier, my electric supplier, that will be 3.6 kilowatt hours times 28p. So that gives, the cost of charging the battery will be £1.4p. So that's not bad for a thrilling fast ride on an e-bike. Hopefully, covering 200 miles. I'm hoping for 200 miles on full charge. We will see. That's just an estimate. But moving on now to another little smart device here. So, this is a little charger. I'll just open it up. So I purchased this little smart charger that's capable of grading all types of batteries. So the main reason I bought it was to set all the cells at the same voltage, or to balance the cells before I place them into their parallel branches. So basically what I do is I set the XTAR, I don't know how to pronounce it, so it's XTAR is the make of the charger. So I set the charger to storage mode to charge or discharge all the cells to a certain voltage before I place them into their parallel branches or their grips within the battery pack. So moving on now to the interesting gadgets of the bike, away from all this technical stuff. Okay, I am at the final stages of this video. I have brought the rest of the gadgets and all the battery components together in view to do my final discussions. I will start with the additional performance parts I ordered after the wind blew the bike on its lid that were never meant to be ordered in the first place. But me being me, I get carried away at times. So I'm going to start with the handlebars. So these handlebars were never meant to be ordered. I came across them when I was ordering the new hand grips. They are the version 2 Renthal Fat Power carbon fibre handlebars. So version 2 are the longer of the types available in carbon at 800mm. Version 1 are 760mm long. So I wanted that extra little bit at the ends there. So Renthal are the leading supplier of performance handlebars from bicycles to motorbikes. The main reason I decided to go with this type, is because they are longer than my standard handlebars at 780mm long. Also, they are lightweight at 225 grams and are very pleasing to look at. So the carbon can be seen on the inside here, but on the outside a black matte finish exists with a gold marking. So this will look really good against the green frame of my bike. One final feature that I wanted was this larger angle seen here. So This height difference from the center of this part to this part of the handlebar is 40 mil. So this gives you that aggressive look from the front. My current handlebars are much flatter. We will now set this out of view and discuss the other items here in front of us. So we're going to focus on the items that were damaged first. Okay, so we're going to follow on here by looking at these grips. So this is one set of grips for the bike. It is the first set that I ordered. They very closely follow the Boardman grips, but they are in some way different. So the lines, the knurled effect, is all positioned different from the current Boardman grips that I could not source anywhere. These ones, as I say, closely follow the Boardman, with the mounts being on the inside and none on the outside. They have the logo here. So the grips that I have coming in the post are DEF grips. They are very similar to these, only the lines, the knurled effect is in different positions. So I think the DEF grips have lines here and knurled right round 3/4 of the grip at this point. They also have the mount point on the inside, but the DEF grips that I have ordered are green. The colour is sick green. Hopefully they match the bike and they look well on the new handlebars. So moving on, the reason I purchased these was because the other ones were damaged at the riverside. So we're now going to move on to the pedals. So the pedals are performance pedals, you could say. They are CNC milled, they are aluminium, they have the manufacturer's logo imprinted on them and a silver white sort of writing and the black background. They also have, what do we see? They have this nice carbon fibre effect in a pinky red colour. So the brand are Rock Bros, and they're very light too. They're very snazzy looking, and I think they will suit the bike very well. So, alright. So there's wee grub screws you can see there for grip, so your feet doesn't slip off them. Not that I will be needing them very much with the 3 kilowatt motor, but they're there anyway. Let's say the battery runs out when I'm 200 miles away from the house. So, the next thing that was damaged on the bike was the right hand side brake lever. So when I say brake lever, it was just this point here. But you had to buy the whole component to get the lever. So I will remove this lever and attach it to my little piston or master cylinder, the mechanism. So we're going to move on here now to other interesting gadgets. I'll place these out of view. So as I say, there's 2 more sets of these grips to come in the post yet. Okay, so what I'm going to do here is I'm going to focus on smaller gadgets, then we will move to the lights. So, we have this bicycle pump. So, it's cordless, it's got a lithium battery in it. The brand is Woo Wind, I think you pronounce it. It's a really good pump. So the battery capacity is not very big, it's only 1200 milliamp hour. The output pressure is 150 psi. So I think this is beneficial for the e-bike. I'll just take it out of the box, sure. So there you have it, it's quite smart. Hold on. A really good wee pump. I've used it many of times. So we're going to move away from this now and focus on other items. So here we have a little rear light. I'll bring it out of the package. It's quite a wee snazzy one too. The battery might be dead on it, which I think it is. I'd never used it in a long time. Never turned it on since I got it. I must charge it. So a wee snazzy rear light. So the LEDs goes round in a circle on it. It's quite cool. So that's for the rear of the e-bike. We have other little gadgets here. So we have this handlebar extension. And we have these little mounts. I'll bring one out of the packet here. So here we have these little fancy mounts that will screw or bolt directly to my carbon fiber handlebar if I decide to use this for the other monitors, such as the monitor for the e-bike controller or the battery management or sat-nav or something or anything like that. So moving away from this, so it's like a little carbon fiber effect. I was going to say it matches the handlebars, but the handlebars, the carbon fiber is all hidden. I don't know why they done that either. I think it would have been nice with the carbon fiber. But that's it. So now on to other little gadgets. So here we have a little connector. An important connector. So it's an XT90. I actually need XT150 for the battery to the controller, to the actual controller for the e-bike. That's only for charging this connector. It's much smaller. So continuous current I think might be 40 amps. Now moving on to this little gadget, which is quite cool. So I have the bolts out of it because I'm changing them to stainless. So this Renfrew stem, I think that's how you, what they're called, a dual stem, this one is. So it's 50mm, I believe it's 50mm from the centre of this hole to the centre of this hole. So this is for the, well, the carbon handlebars. It's not required, but I decided to match the handlebars to the stem. So you can see it's black and gold too. It's obviously anodized, it's CNC milled, machined, and it's very light. So we're going to move on now to the mudguards. So we're getting through this rightly. Okay, so we have the rear mudguard. The type of mudguards is top peak. These are meant to directly fit to my bike, but there are issues with them, with the front one. There's a lot of bad reviews about it, so I'll get into that in a minute. So I've made a modification to make the front one fit my bike. So this is the rear mudguard. It's also quite cool. You can adjust it here at this point. Very snazzy. It's for a 29er bike. So we'll get the front one here now. So the front one, you can see there's a bracket here in the middle. So there's a lot of bad reviews about these mudguards falling off, the front ones. I know why they're falling off. It's because the way they have designed these mudguards is they don't fit up into the crown of a bike. One of these mountain bikes. So what I have done is I have designed a spacer to fit in here at this point, so the little clamp can directly fix to the point it's meant to fix to. So at the minute, this mudguard is not getting into the crown or the shaft part of the forks. So what I have done is I have 3D printed this little clear block to directly, so it bolts directly underneath this clamp. I'll demonstrate that. So it will fit here like so. I've got the two little stub, the wee extruded bits that sit into the mudguard. Then we have the clamp like so that sits up further into the crown of the bike. So yeah, very good. So we're going to move on to the lights here now. First things first, I'll just show the helmet. So this helmet I purchased obviously to protect my head, but it's a very snazzy looking one. I wanted a helmet with a bit of green in it to match the bike. I still need to get a mount for this, and I will explain why I need a mount for it now. Okay, so I've brought all these gadgets, these components, into close proximity to give the final discussions here. I'm going to first start with the lights. So at the very start of this project, or this, I could say, when I purchased the bike, I wasn't expecting to turn it into a big project, but well, there you go. So at the very start, when I purchased the bike, I wanted lights that, well, would turn nighttime into daytime. So the reason I wanted that is because when I go out trail riding at night through a forest, for example, you want lights, really bright lights, so you can see where you're going. You don't want to go overlaying the cliff. So I done a lot of research into lights, different lights, and I seen that Magic Shine was producing probably the brightest lights on the market. So these are known to be the most advanced bike lights in the world. This one is a new model. These are the older models, but they're still really good lights, the best on the market. So I wanted one for the helmet, and I also wanted one for the handlebars of the bike. So that's why there's two version 2 8000S Montier lights here. So I'll just open this one up. So they come with this, I think it's a 10,000 milliamp hour battery. So they have this little sturdy bracket that can be fixed directly to the handlebars. I still have to get the mount for this light to the helmet. I haven't got it yet, but it's not that expensive. So that's these lights, the 8000 lumens. So they have a dip beam and a full beam, and this can be controlled using this little small remote. This will be placed on the handlebars also. So this can be programmed directly to this light. I've already done that. So moving on now to the newer model. So this is the Beast. I'm going to call this the Beast. Just to give a little example here, these Montier 8000S version 2, the brightness of them is way brighter than a car. So I think your typical car nowadays, well, the HIDs is 4000 lumens or thereabouts. This here's 8000 each. This new model is 12,000. Also, just to give another example here, your typical traditional halogen bulb is around 800 to say 1200, 1500 lumens. It's not very bright compared to these. So this is the new model. So when I had these ordered, well, they were there for about 6 months. Then this one came out. So this is why you see the 12,000 now, because I wanted the brighter one for the handlebars, and then I will place this 8000 lumen one on the helmet. So I will open it too, to show it off here, to demonstrate it. So the idea here is to place this in the middle of the handlebars. It's 12,000 lumens. It's got the remote also, dip beam and high beam, and the different settings, how intense you want the light. and it's got different functions. It can flash also. So I think I've talked enough about those. So I'm going to move on here now to focusing on the battery pack, the gadgets, the components purchased for the battery pack. Okay, so I have everything tapped out of the box. Don't worry about this piece of foil. That's only there to protect the heat shrink. So this is just a wrap for the battery pack. So I'll just get this out of the way. So we have different sizes here. The length of each one of these bands of shrink wrap are 1 meter long. So when I say band, there's 1, 2, 3, 4, 5, 6 different sizes there on top of each other. This one here is the smallest at 220 mil. So that's 220 mil diameter by 1 meter long. The reason I've got so many different sizes right out to 400 mil here or 380 mil is because my battery is shaped like a triangle. So the wider of them all, the 320, I think it's 320 or 60, not sure. It looks longer. Maybe it's 380, I'm not sure. But the wider one is there for the broader end of my battery pack. The 220 mil one is there for the point of the triangle or the point of the battery pack. So that's all that's for. It's black. It's a nice colour. I didn't want to get blue. I will have the battery pack hidden under stainless steel, but the black's there anyway. So now moving on, we're going to start here with this barley paper. So this barley paper is there to act as an insulator. So this will be placed on top of the nickel strip or the copper strip. It will also be placed down the inside of my battery pack. So in between the two banks, bank 1 and bank 2. Also there will be a piece of fiberglass in between the bank 1 and bank 2. I'd just like to point that out. So moving on, we will now look at these little pieces here. So again, this is just more barley paper. These, I bought the green for the negative part of the cell and the red for the positive end of the cell. So this is not important at the negative end. This is not required. I could place them over the top of the nickel strip, but this barley paper is there for that reason. But these red ones are required. So if you look at these closely, you will see there's a little bit in the middle that can be taken out. So this will then be hollow. So this is so the nickel strip or the copper strip doesn't arc to the body of the cell. So they're really important. We'll place these in the box. So now moving on to this tape. So this tape is there to support the outside of the battery pack. So it has fibre strands in it, right around it. That's all that's for. So we're going to move on now to the most important part of the battery pack. Well, everything's important, but this here is for the, well, all these bands and these strips are for the connection of the cells. So I'm just going to touch on these ones, these copper ones first. So here we have 10 meter rolls. The width of these copper strips is 15 mil. The thickness is 0.3. So that's quite thick. In order to weld these to the cells, we need a good welder. We'll get to that in a moment. But there's 40 meters there. So placing this in the box. So the reason I'm using copper is because copper's a better conductor. It can carry more current than the nickel. So the nickel is there too. So we have 0.2 times 8, and that's 10 meters. We have 0.2 times 10, so that's 10 mil wide. That's 10 meters. And we have another 0.2 times 8, and another 0.2 times 10. So that's pure nickel. The last thing we have here is these 3 wide nickel strips. So, well, we have this copper too. So this is just another copper strip, 0.15 times 10 mil wide. So this is 5 meters. I might use this, I might not. It's not as thick as a 0.3, but it's there if I need it. My knees are killing me now. So, we're now on to these bands, these nickel bands. So each one of these is 0.2 mil thick. We have, what do we see? We have 2 position, we have a 3 position, and we have a 4 position. So these is there for the parallel connections, or they can be used for the series connections depending on the battery configuration. But you can see that they are shaped in a W, sort of like an up down small angle, 30-degree angle. So this allows the cells to be placed nice and tight together. So that's it, everyone. We're going to now move on to this welder system. So I will bring this out of the box and give a little discussion about it. So we'll move this out of the way. Okay, so I'm going to finish this video up nice and quick. My knees are red raw, kneeling on this carpet, discussing all those items today. So we're going to focus here on this glue gun. Then we're going to move to this box of battery accessories, the battery pack accessories, and then we will focus on this state-of-the-art welding machine. Then we will finish the video off by giving a little outro, shall I say. So starting with this glue gun. So I have a glue gun in the shade, in the garage, but it's not a high wattage. So when you go to squeeze the trigger and you're trying to get glue out of it, the gun can't heat the glue quick enough. So the trigger becomes hard, and it's quite a useless device. So I purchased this really industrial-like glue gun, which has a brass end that can be changed. So it's a high wattage. I think it's 100 and something watts, maybe 150, but I'm not sure now. But the model of the gun, the make of it, is B-Way. So you can see it's really well made. I also purchased, well, first, these 150mm glue sticks came along with the kit. So the kit being this little case, swanky case, and these glue sticks. But the problem is, they're not going to last that long when I'm going to glue the cells together side by side, if I do it this way. So I purchased these glue sticks, which are very yellow looking. So these are 300mm long, they are 12mm wide. So a lot of glue there, if you look at it this way. Now they've fallen everywhere. So moving on from this, we're going to look at the box of gadgets, the box of the accessories for the battery pack here. Then we'll move on to this welding system, which is one hell of a piece of equipment. Okay, so my knees are red raw from being on this carpet. So let's finish this video off by giving a short discussion about this welding machine. Okay, so here's a box of accessories. We'll talk about the machine first. I just whacked that machine off my leg here. I'm sore myself. Okay, so here we have the Glitter 811H Industrial Energy Storage Spot Welder with real-time monitoring, high pulse power, 42 kilowatt. So this is the most advanced machine of its kind. You get a model, a 36 kilowatt model, but this is the 42 kilowatt. So I selected this machine because it's capable of welding copper between 0.15 to 0.4 mil thickness. So that's perfect for my battery and welding all the cells together, because I'm using 0.3 of course, with a bit of nickel on top of it. So we're going to look at this box of gadgets here, or accessories. So we have the power cable, we have the foot pedal, so this is to start the welding process. Then we have these cables, which are thick. So this is well, the rated 75 amp 50 mil square welding pens. So you can see the 75 there. So these electrodes on the outside can be changed, so they're interchangeable. I purchased, what do we see? 1, 2, 3, 4, 5, 6, 7. 7? 1, 2, 3, 4, 5, 6, 7, 8. I purchased 8. I was thinking there, why would they send 7 and not an even number? So 7 spare electrodes. I don't think I'll need them. I think these ones will do. But again, I like being in front rather than behind. So just in case. So this machine also, well, I'll plug this in just to demonstrate this. So here we have a little port that we can plug this, well, these two pens in. What do we see if I get them plugged in here now? When the pressure's on. Okay, there we go. So these pens are there to check the resistance between the cell and the nickel strip once it's welded, or between the copper strip and the nickel strip. So it's to check the resistance between the different connections of the battery pack once the battery pack is all welded together. Well, once the nickel strips and the copper strips is welded to the cells. So that's it, everyone. We're not going to focus on that too much. I will demonstrate this machine working. I think it will be part 3, 4 and 5. So we're going to move on here and finish this video up. Okay, so I've decided to finish this video off by attaching the mudguards. So the front needs modified, the rear doesn't. So we'll mount this, then we will finish modifying the front mudguard and we will take it from there. So this is just clamped on, like so. There we go. So that's the rear done. We're going to move on to the front now, doing a final modification. Okay, so I'm shining a torch in there. So you can see the clamp there when the mudguard's in position. So if you look at the top here of the mudguard, you can see how it's sitting where you would want it to sit. But the problem is you can't push it up any further because these sort of perpendicular edges sort of be pressed out in an angle. So you're putting force on the mudguard. So I'll demonstrate that. So if I push here at the bottom of the mudguard, I can't really do that at the minute because the screw's tight, but if I push here, there you go, I'm putting pressure on these perpendicular edges. We don't want that. We want this down in its in a nice position like that. So what I have done here is I have 3D printed this little block, this spacer. This spacer will go on between the mudguard and this clamp. So what I'm going to do here now is I'm going to take it off. We're going to do a wee modification to this stainless steel bracket, and we're going to add the bigger 8mm bolt also. So it's a stainless steel dome head bolt. I will do that now. So it looks apart. Okay, so we're going to set the mudguard over here for a moment. So here is the clamp mechanism. So the way this works is when you tighten this screw, this bolt, these two tapered bits spread out like so and clamp the tube in the front forks. So what I'm going to do here now is I'm going to remove this bolt that came with the mudguard. So this is the 5mm bolt that came with the mudguard. What I have done is I have now replaced it with an 8mm bolt, and I have heated a nut up to, well, nearly glowing red, and I pushed it into the plastic block. So what I need to do now is I need to make this hole bigger on this bracket to suit the 8mm bolt. Then we will attach it back onto the bike. So here's the 8mm bolt going onto this adapter, this little clamp mechanism, I should say. So much stronger already. So as I say, I have melted the plastic by pushing the hot nut into it. So the nut is locked into position. So we will do this bracket now. So the hole I need to make bigger is this middle slot. So we'll just see if that fits. Nearly. Okay, there we go. So we'll fit this to the bike now. So this goes on like this, and this goes on like this. So perfect. Okay, so I forgot there. I have to make the hole in the mudguard bigger to the plastic. So I'll place the bracket in position, and we will use the Dremel again, carefully this time. Okay, that should be it. There we go. So the next thing that I put on here is a spacer. So I have a spacer in the bag here because it's one that, well, it wasn't lying out in the sunlight. These spacers are lying out in the sunlight, so they're quite yellow. So I place this into the, well, onto the bolt. So you can see now how it's taking place, or taking position. So then we put on the clamp. So the clamp, the two prongs, goes down into my little spacer that I have made. Like so. Then we have this top piece. So that's it. So we're going to put it on the bike here now, and hopefully it works out, which it should do. So very good. Okay, one final discussion here before we move on to the outro, the end clip. So I wasn't planning to do this in this video, but I think it keeps part 2 shorter by doing this now. So this spacer adds 15mm from this face to the actual clamp. So this means now that this clamp is fully protruded or entered into the crown. So we will just demonstrate that now. So there we go. Well, if I push this up into position like so, and I tighten this domed head screw, these clamps will expand out, and now the mudguard sits where it needs to sit. So hopefully that makes sense. So that's the bike ready for part 2. I will just get an Allen key here and I will tighten this up, and I will also add the model of these spacers if anybody wants to copy them. So there's 2 of them lying on the ground here, the yellow ones. So these closely follow the clamps, the same perimeter, the same little spigot spikes. that sit into the adapter. So there we go. So we'll get the Allen key and tighten this and do a final wee clip here with the mudguard tightened. So to finish this task off, all I need to do is place the mudguard in position and tighten this new domed head stainless screw until I feel the clamps gripping the tube part of the shock. Okay, there we go. So nice and rigid. Obviously they're designed to spring, but at the mount point here, everything is nice and rigid. So I can tighten this on up yet. I'm not going to go any more than that. So that's it. Brilliant. So here we have the spacer modelled and ready to transfer to the printing software for the 3D printer. So the larger hole seen here in the middle allows the 8mm bolt to wiggle once the tightening takes place or once the two tapered parts of the clamp come together. So in the video clips the hole size was 8.5mm. I have increased this to 12mm for this reason. So once the tightening sequence occurs, the bolt will sway, not stay in the center because of the clamp design. So a bigger hole is important here, or the mudguard clamp will be restricted, or in other words, the fender will fall off. So these little extruded parts seen here, these extruded features, these are layers so that the spacer sits into the mudguard as did the clamp on its own. I have also added these additional holes seen here so that the bollards on the existing clamp sit into my spacer, keeping the spacer and the fender parallel to the wheel at all times. So once this model was complete, I then transferred it to the printing software seen here. So 4 spacers are attached to the printer's head. So this is simulated by the software. So these spacers are positioned just as they were once the printer printed the spacers. Okay, as promised, here's my e-bike project cost breakdown itemized list. So everything's on this list, from the bike to the sails to the e-bike kit to the magic shine lights to the death grips, and then we have this middle group here which is the battery components. So that will be the copper strip, the nickel strip, the shrink wrap, everything like that. Then we have this little list at the end here. So this is the items purchased from here up. Forget about this list for the meantime. So the tools, the little machine, the industrial energy storage spot welder machine is there too. So it's quite expensive at £460. We have the hot glue gun. We also have the spare electrodes. So, yeah, there's a lot there. It's quite expensive. Quite a really expensive project. So it's touching £7,000 already. And we're not finished yet. Okay, so I've decided to switch out a few items on the list for one reason and one reason only. So that's to increase the performance of the e-bike build. So I decided to move from an 80 amp controller to a 150 amp controller or even a 200 amp controller. So this is to get or to retrieve more power from the bike. So more top end and more torque, more takeoff power. So I'll go down here to the bottom of this list. So I'm now looking to purchase this stealth bomber 200 amp e-bike controller. So this is expensive, so I'm not just going to pull this money out of anywhere. So I have to save up for these components. So at the bottom here we have, the bottom of this list, we have 2 more items. So we have the 5000 watt QS motor, and we also have the 8000 watt QS motor. So I haven't decided what one I'm going to go for, but I probably will go for the bigger one, the 8000 watt. So doing that, I should increase the bike's performance by, well, a huge amount. So if I was to multiply the 200 amp controller by the battery pack, which is 72 volts, I should see a power output of around 14 kilowatt or 14.5 kilowatt. So that's a lot. That's within the, well, 80 miles per hour range. So I was thinking overnight, why am I going with a smaller kit when I have a battery that's capable of supplying much more power, so a higher current. So that's the reason I've decided to upgrade here. So we're going to finish this video off here now. Okay, so I've had a serious think overnight, and I've decided to upgrade the controller discussed throughout the earlier video clips. So this is an 80 amp controller. So this will provide peaks of 5 kilowatt within this e-bike. So I want to upgrade now to a 200 amp controller, and I also want to upgrade the motor. So the hub motor itself, I could run with a 150 amp controller with the current hub motor, but there's chances that it could burn up. So the motor could heat a lot if I was to pull 150 amps through it. So I've decided to upgrade the controller to match my battery pack. So my battery pack has it will have a continuous discharge current of 200 amps. So that's continuous discharge current, so that's safe working load. So yeah, so this 200 amp controller should take the bike right up to 14 kilowatt or a little bit over it. So yeah, so I need to source a new motor for the rear end, the rear wheel, and yeah, we'll take it from there. But first I'm going to purchase the controller. So I hope you enjoyed this video. Please hit the thumbs up if you did. It's a project I've been meaning to cover the past 6 months or so. If you want to see this project evolve, please subscribe and hit the post notifications bell to see the latest from my channel. Also, other interesting projects will follow soon, such as my mechanical iris, my aperture, and my unique smart glove, maybe. So thank you and goodbye everyone.